Cool. So, um, for our session today, first we're going to talk about Excel and its uses and applications in STEM. So this workshop was initially advertised as an Excel for Engineers workshop, but we've now broadened that so that it's pretty applicable to anyone in STEM really. Um, we'll talk about how you can use it, why it's important and why it's good. And then we'll run through the Excel tabs and kind of get a look as to what Excel is and how you can use it in different applications. Um, we'll then do a bit of an introduction into basic Excel functions, and we have an example problem to work through, which I'll give you guys a link to shortly. And then we have an additional example for you guys to complete when that's done or to do as a homework-ish activity to learn Excel a bit better. And then we'll have our session summary questions and our close. Some of you might have noticed we do have Mackenzie with me. She is just helping out for the session. She'll be essentially messaging you guys to get your names and student IDs. That's literally just so we can send out the recording afterwards, just so we know who registered and who we can give out recordings and to make aware of any future workshops and whatnot. So don't mind her. She's just doing that just to collect that data for me. Great. So I guess we'll get started. Not on that. The first thing I will do is share my screen. And I'll give you guys a bit of a run through on Excel. So for those of you who know me or have seen me before, I am a pass leader. So typically I do run sessions in a pass-like manner. Unfortunately, because we only have 1 hour to go through a lot of content here, I can't really do that. But if you do have any questions, do feel free to pop them in the chat, and then I'll try and answer them either at the end or as we go along. So this is the Excel screen. So hopefully you're at least somewhat familiar with that. What we've got here is this is our main workbook. So this section here is the main part where we typically work through different functions and different interactions with Excel. So this is similar for the most part to most of your Microsoft Office suites. So you have your typical text alignment and text modifying functions. The only difference here is we've got a few extra little buttons here that help with formatting and different analyses using Excel. So I'll go through these in a bit more detail in a second. I'll just run through each of the tabs first just to get an idea of what everything is and why it's important. So our insert tab, again, similar to other Microsoft programs, in the sense that we can insert tables, shapes, smart art, and so on. This part here, very important for particularly those of you who are doing either capstone or work integrated learning or thesis projects, because you'll need to know how to present a lot of your data. Now, one of the, I guess, main questions I get asked when I'm, doing these workshops or I'm talking to people is the whole Excel versus MATLAB argument. In my opinion, I significantly prefer Excel over MATLAB. It's not like it's a right opinion or a wrong opinion. Other people have it depends. It's everyone's preference. I just prefer Excel because firstly, it's free. Free for students. I mean, you guys can get it for free as part of Griffith students. Whereas MATLAB is actually quite costly to get the suite. It has a very user-friendly interface, so it's very easy to use, and it's very straightforward in how inputs are converted to outputs. So particularly for beginners who might not have the best understanding of data analysis or how to work with data, Excel is very useful, whereas MATLAB might be a bit more challenging. That's not to sway you against using MATLAB. I don't want to do that. I'm just letting you know what my preference is. Yes, you should be able to see my screen, Kai. Can no one see my screen? You should see in Excel. You can see it? Okay, cool. Then you might have to refresh. Thanks, guys. Yeah, so as I was saying, so just a preference, I prefer Excel over MATLAB, but I don't want you guys to just only use it. Try out the two if you have the opportunity. This is just what I've tended to find more helpful. So for your data analysis, you'll use a lot of these charts here. The rest of it is, again, pretty straightforward to other Microsoft programs. Page layout, again, very similar. This is talking about your design, margins, orientation, and so on. Again, not too important. The only thing here I might draw your attention to is this grid lines thing. If you press the print, it shows you how big a page would be. So it draws those lines out for you, which is quite useful if you're looking to print Excel documents, but typically it's not as required. But I thought I would show that anyways. Formulas. Now, there's a couple ways in Excel you can do formulas. So you can look through these, and particularly if you're quite new to Excel, I would recommend having a look through these. This is pretty much everything you can do, or all the things you're capable of analyzing your data with. So the ones we'll probably be using today are the math and trig ones. So if we click here, and we'll use things like summations. So here, sum. And the good thing about Excel is it tells you how to use that formula. So in this case here, it says sum. You would type sum bracket number 1, number 2, and it would add all the numbers in a range of cells. So it's quite useful in the sense that it tells you exactly what you need to do to achieve what you want to do. Now, the only thing is you might not know how to get to what you want to do. So there's a lot of forums and things like that on Google that you can find where if you just look up what you're trying to do on Google, Excel will have a function for it. And you can figure out what that function is based on that, and then you can apply it here. So there's a whole range of different things that you can do there. There's different lookups, ways to manage your data. There's things you can do with date and time. You can convert numbers into date and times and things. Text, so you can do a whole lot of text altering. You can replace text. You can join text, split text. You can remove parts of text. You can convert text and so on. So there's a whole, again, another list of things there. This is one of the bigger ones. So it's the logical arguments, and this is where Excel starts to get really good in its power, in the sense that we can start to introduce functions that have and, if, or statements. So this is where we can start to play with data and to say, if we want something to occur, then do this. And this is where you can start nesting formulas and start doing different things. So for example, I won't go into the financial one, but financial money stuff. But for example, we could have, say if I've got a few numbers here. So I've got 2 to 7 there. You can use different statements to tell you what you want Excel to do. And as I mentioned, you can either use these books here in the formulas, or you can just click on this little tab up here, and then you can start writing your formula and writing a reference to what you want to do. So, for example, if I wanted to do something basic as in a summation and I wanted to sum all those numbers, I could type up here, or I could just type on the cell here, equal, and then if you remember from before, it comes up with sum. So this is how you'll start every formula you want to use. It'll always be equal, and then the name of the formula. It's not case sensitive. It can be equal sum in lowercase. It'll just automatically convert it to you. So then you put it in brackets, and it says number 1, number 2, etc. Now, you could do, as it says there, number 1, comma, number 2. So we could do like that. And then close the brackets, and we get an answer. But that kind of defeats the purpose of what we're trying to achieve really with Excel. We're trying to make things a lot more streamlined. So what we can do is just click and drag, and it'll give us the sum of our whole data set. So we can see there we're doing equals sum E12, so E12 to E17. Then if we press enter, we get the same result. So we can use Excel for a lot of this data automation, and that's where it starts to become really quite handy. Then if we're talking about the logicals, because the logicals are another thing that's probably going to be quite relevant and quite useful. For example, you can tell Excel to put different values or different things based on those logicals. So we'll start with this simple one. So what I'll do is I'll say equal if, because that was one of our logicals. So this is saying if something is true, so if a condition we specify is true, then put this in this cell. So let's say in this case, if that cell is greater than 4, for example, and we put a comma and it tells us the value of true. So let's say if that cell is greater than 4, then let's write here greater than 4. So just note with Excel, if you are putting a value, so a number, then it's fine. Like you can just put it without these little quotation marks. But if you're putting something where it's going to be a text string, then you need to put your quotation marks in so it knows that you're not trying to do a formula or something there. So if that number is greater than 2, greater than 4, put greater than 4. If not, let's put less than 4. So when I press enter, who can tell me what that should show up? What should come up now? What should the output be? Less than 4, perfect. So it comes up less than 4. Exactly. So now we could do the same thing. I could go here and do the same formula, type it in equal if, blah, blah, blah. If I wanted to do it for that whole data set though, that becomes a little inconvenient. And especially if I did something like this. So for those of you who don't know, you can, if you've got numbers that are in a row like that, you can highlight the numbers, press on this little square in the column on the corner and drag it down and it'll make a series. I can do something similar with this. So here, if I drag down 1, you'll see it automatically changes this formula here from E12 to E13. So it drags that formula down. So let's do that all the way down now. And we can see here, 5 is the first number greater than 4, and it changes it to that. And this applies to all Excel formulas. You can do that with everything. So that's just getting you a bit of an introduction to those formulas and how they work. So very important, would recommend going through them and seeing what you can do or what you need to do with your data. So this is probably a bit more advanced, so I won't go too much into it, but this is where you can start to validate and manage data and to start to use it a bit more effectively, but I won't cover that today. Review, exact same as Word document, allows you to add comments, allows you to protect your workbook, protect cells, and so on. View, this is all pretty much the same. There is only one thing here I did want to bring up that is a really amazing quality of life tip I found. Say I've got a lot of data. For example, say I've got data that goes, I'll go A, B, C, D, and it goes all the way across here. And then let's just put a random number in each cell. So let's put rand between, because I want Excel to tell me random numbers between, let's go 0 and 50. So again, one of the formulas. Now what I'm going to do, I want to fill a lot of data with it. So I'm just going to drag this across and then drag it all the way down. Okay, so we've got a bunch of random numbers. Now to prevent my computer lag, I'm just going to paste the values rather than formulas. Now, say I am working over here. So I'm working somewhere over here. Let's copy, paste these over so I get bigger data set. Now, say I'm working over here, but I need to reference those first columns. Say they've got like names, so people's names. Let's call this name 1, name 2. Now, say I'm working over here, and I'm looking at the data here. I can't tell which person this data belongs to. I've got the names all the way over there. What we can do in Excel is if we click on a cell, for example, here, we will So note that we are the first cell to the right of our names and to below our letters. We can press this freeze panes button and press freeze panes here. And what it does now is when I move, no matter what, we're always going to have our names and title up here. So this is really useful when we're trying to mark different position or to see what corresponds to different things. Then we'll unfreeze. You can do this with any cell you want. So I can go here if I wanted to, freeze those panes, and it'll freeze everything above and to the left. And again, same thing. So there's no limitation on that, but it's just a useful trick to note. So just keep that in mind. It is quite a helpful aspect. So that's the freeze panes in the view. So that is pretty much it in terms of getting to know the actual program. Hopefully that was quite straightforward. What we will do now, though, is we'll get into a bit of an activity that'll hopefully make it easy to kind of see this in practice. So I've got a little link that I will post. So if you guys want to follow along with me, you can get the exact same questions I'm going to be working from in that link. And we'll work on the first question. So I'll give you guys a minute to get that up. All right. Have we all got that link or that those questions downloaded? Perfect. All right. So the first thing we're going to do is see the table there that we've got in question 1, talk about car type and then purchases. What we're going to do is just copy and paste it into our Excel document. Nice and easy. So what we want to do now, just because we want to make it a little cleaner, we'll double click on this little line between the cells. So what this is going to do is effectively expand the cells to fit the text. So I double click, well in this case it doesn't like it, but we'll expand it out. And then this one I will do the same for female purchases. And then we'll shrink that down. So the double click works on that one. Now, we've got a few questions there. So what we want to do, or the aim of this, is to do a bit of probability. So it's not necessarily a demonstration of your understanding of probability. That's just the question. But we just want to see how we can apply it in Excel and what we can do with different things. So first question we have, it says using Excel, determine the total number of males and females making purchases from this survey. Then create a graph, a column graph showing the percentage of each car type being purchased by males and females, and label each axis appropriately. So what we're trying to do with this aspect here is to get a bit more of that data presentation skills and understanding shown there. So first thing it wants us to do is the total number of male and female purchases. So what I'm going to do down here is make a column called a row called total, and then that's what we're going to do here. So similar to what I showed you before, we're going to use our equals sum, and we're just going to add these columns here. So 78 total purchases by male. Now I'm using the same formula, but I want it with this row here. So I'm going to take this little box, drag it across, and we can see we have 81 purchases by females. So slightly more there. So that question, very easily done. But now it wants the percentage of each car type being purchased by males and females. So this is where we have to do a bit of work, because this here is just in numbers. It's not in percentage. So what we're going to do is make a new table. So I'm going to copy the car types, paste it here, male, female, paste it here. Now this is going to be the percentage. So there's a few ways we can do this. So the first thing we can do is a normal formula. So if we're trying to figure out the percentage of something, we want the number of purchases in this case over the total. And we want that to be converted as a percentage. So if we are looking for percentages of each car, what we're trying to do here is compare to the total amount. So what we need to do is see how many people in total are buying each of the cars, because then we can figure out what are the percentages for each car type. So what I'm going to do here is put like a grand total. And this is just going to sum equals sum, or actually I'll just do that plus that. We know that in total 159 people were involved in this survey. So if we're trying to figure out the number of purchases of a Fiat, what we would do is equal the number of purchases, in this case 3, and we're going to divide it by the total, 159. Now, we can see there Excel automatically gives us our answer as a decimal. And there's a few ways we can convert that into the percentage that we're asking for. We can either multiply this by 100, so typical conversion of decimal to percentage, and we get it's 1.88%, which is fine, but again, not very efficient. What we can also do is click, and I'm going to click here. We can press this button here. So this button always converts or formats things as a percentage. And similarly, these values are a lot of your data or number changing values. So you can convert things into money. So that'll put it in a format. So for example, if I had 58.72 and I click on the money, it'll convert that into an accountancy form for me. So, and this one converts things into numbers. So what we want is a percentage. So I'm going to click that, and it automatically puts it as 2%. But if you remember, we had it as 1.88%. So where we have these decimal things to come in handy. So this one here increases the decimal value, so it shows more decimal places, and this one shows less. So what we're going to do is click this a couple of times, and we'll use it as 2 decimal places. Now, what we'll do is make sure that that's the case for all of them. And now, similar to what we did before, we're going to go across here and go down here. But what you'll notice is we get errors in every single cell. So now we need to figure out, why do we have errors in each cell when we've done the exact same thing that we did before with the summation? We summed them here and we dragged across. Well, what we can do is actually click on the formula and see what it's doing. And we can see here, so this one was right. It moved the female purchases, which is what we wanted. But here we've moved a cell over when we were calculating the grand total, not what we're after. If we look at the male ones here, it moved it down. So that one was correct, but it moved that down. And now this is where we can start to do a few different things. So let's go back to this original formula. So I'll undo those. In this formula here, we can see that we are dividing C5 by C13. But what you can do with Excel is actually lock your cells. So what you can do is make sure that it doesn't move when we start to change or to move cells. And we don't want to lock any of these top ones because we want it to move freely, but our grand total is not going to change. So what we're going to do is click on the C13, which is this grand total, and we're going to press F4. And you'll see now that $2 signs come up. So these $2 signs means we've locked the rows and we've locked the columns. So it is not moving no matter what. Now we can press enter. Now we can do the exact same thing we were doing. And thankfully, when we highlight all those down the bottom here, we can see we sum to 100%. Perfect. Now, so we have the percentages there. And now we have to create a column graph that shows the percentages of each car type being purchased by males and females. So now is how we start to present our data. So let's go to our insert tab, and we've got different charts here. So what we want is a column graph. So we want something that looks like this. We're going to click it, and we're going to click this first one. What you should notice is that it comes up blank because we haven't selected any data yet. So we're going to right click, we're going to press select data, and then we come up with this screen. So this first panel here is always our y-axis. So this is all our values in our vertical direction. And these are our horizontal labels. So first thing we're going to do is press add on our y-axis, and then it says, what are your series values? So we're going to click, and we are going to do all the male purchases. And we're going to press OK. So now you see it gives us all these percentages with just blue charts, which is fine. And we're going to give it a name. So we're going to press this little arrow, and we're going to click on this to tell it that the name or the title of those is male purchases. And we're going to press OK. So now we can see here, we've got our male purchases, which is this data, but our horizontal axis has only given us numbers, 1, 2, 3, 4, 5. What we're going to do now, though, is because we want to label our axis with these car types, we're going to press edit, press this arrow, we're going to convert it. So we're going to highlight those, press enter, and then OK. And now we can see we're starting to get a bit more clarity. For now, ignore the fact that we've put a title on the top. That was an automatic. What we'll do now is we will go add here, and we'll do the exact same thing with the female purchases. So in terms of the name, it's female purchases, and in terms of the values, it's these values. Press OK, press OK, and because we've got the data there, we don't have to change it in this category. The only thing we'd have to change it for is if we got rid of the male purchases, but for now, it's OK. Then we'll press OK. And now we can see and compare how much, what was the percentage that each car type was bought by males and females. But we don't have that much information with this graph at this point. So what we want to do is give it a few helping bits of information. So if we click on the graph, it automatically comes up with this chart design thing. So what we're going to do is add a chart element. The first thing we're going to do is add some axis titles, primary and vertical. And then we're going to give them some labels. So we'll call this one car type, and we'll call this one percentage. Now we have a bit more information as to what we're trying to find. And now what we'll do is add a legend. So we'll go here, legend, and we'll put it on the right. And then again, we can click and move it around, move our graph around, and make it a little bit neater. So now we have a bit more data there. Let's move that down a bit there. So now we get a lot more information. The only one thing I would caveat for you, so now you can move, you can copy, paste, etc. So you can put this straight into a Word document for a report. The only thing I would add here for you guys is just when you are using this or formatting in reports and things, you need to have a title. Where should I put the title of this chart? Does anyone know? Who wants to have a guess? Top A1? Not quite. So if I put this into a Word document, where should it go? Bottom, correct. When we format it into a report, this should always go below below your written report. So I'll get up a Word document for you, and I'll copy and paste this. So hopefully we can see that there. Go to home. So hopefully you should have some text written before it, and then you'll have your graph. What we want to do, typically, you want your title of your graph always somewhere below, and you might have it written something like this: Figure 1, comparison of car types and percent ownership by gender. And this is how, for all your courses, all your subjects, you should always present your graphs. No matter what kind of report you're doing, never put the title above it, always put it below. And it should be something like this. It shouldn't be called graph or image, it's a figure. So you should write figure 1 if it's your first one, and then the title. And then you go down and you keep typing your report. So this will give you a nice clean presentation and it'll look really consistent throughout. There's a few other things you can do with this. For example, you can do this in Excel or here. You can double click it and then start to change borders, colors and things. So normally what I'd like to do is put everything in black. So I'll change that to a black line. Change different parameters. Give it a bit more. I'll usually get rid of those lines. Then I click the thing, make sure all the text is black. Make sure our titles are bold. And so on. So you can see it already looks a lot cleaner, just like that. So have a play around with that. Double click and your formatting and have a check. If it was a table, should the title also be at the bottom or top? If it's a table, it's different. So if you've got a table, so let's actually copy this table here. So if we have this table, your title should actually be on top for the table. So here we would do something like table 1, data of male and female car purchases. So figures go below, tables go above. So that's how we should present it. And this is common. This is not a specific case. This is a general rule in any report writing. You should always structure your tables and things like this. Yeah, table top, figure bottom. Is that okay for everyone? Does that make sense? Does anyone have any questions at this point? So far, so good. Okay, so I'll close that now. Okay, so we've done that aspect. We've done a bit of presentation. You forgot how to get the male female purchases on the graph. So that one is where you right click, you press select data, and then you add data. And then you would obviously click on whichever value it is. This is recorded, guys, so if you have missed anything, you should be able to go back and follow it, so don't stress. I've got a Mac, is using number on Mac. Should I consider getting Excel or numbers is fine? I've never used numbers. As I mentioned at the start, Excel is always going to be my preference just because of how powerful it is while also being very easy to use. If you can do the same thing with numbers as you can with Excel, then that's fine. But I've given you my preference, and yeah, typically at uni, Excel is the preferred choice, or MATLAB. Okay. So now we'll get on to some of the questions. And what I'm going to do is copy this percentage graph table over here. Oop, I'll copy it as values. And keep them as decimals there. And the reason I want to keep it as decimals is now because we're going to do probability stuff. So because we're doing probability, decimals are better. So the car dealership, if we look at the question, wants to determine the probability of certain cars being purchased by their clients. And then it gives us a caveat that and is typically multiplication and or is addition in terms of probability. So again, this is not something that's necessarily specific. This is just part of the problem that we're doing. And that's how probability works. But we have to determine what is the probability that a male making a purchase would buy a Fiat, and what's the probability the female would buy a Mercedes, probability a male would buy a Ford or BMW, and probability that a female would buy Nissan or Vauxhall. And finally, probability that two females would purchase a Fiat and Mercedes in succession. So we do need to change these a little bit because these are talking about the percentages with respect to the totals. So if we're talking about probability that each individual would buy one of these cars with respect to the other, we need to know what is the total number of purchases of each of these cars. So what I'm going to do is delete all this again. And here we're going to just do a sum of each of the cars. So we're going to click that, drag that down. Because we need to know, we're talking about male versus female in terms of this question. So if we're trying to figure out the probability, what we're going to do here now is equal that divided by total. So it gives us it's 10% male, and then here we should get 90% female. Of course, we've got an error because we haven't locked it. So what we're going to do now is we're going to lock only our E column because we want it to move down, so we don't want to lock the number. So we just press F4 3 times and we get the E column locked. Now we're going to move to here and all the way down. So now we can see each of these should add up to 1. So if we look at the bottom, each horizontal row does add up to 1. And just to make it easier, let's work with 2 decimal places. Cool. So now we know we can use this to determine probability because there's a 10% chance males will purchase Fiats, for example, and 90% females. So for the first question where it says, what is the probability that a male making a purchase would buy a Fiat? What is the answer? So what's the answer to A going to be? This one is just reading off the table there. So who can tell me, what is the probability that a male making a purchase would buy a Fiat? Yeah, 10%. So it's 0.1 or 10%. Easy. So B, what's the probability that a female making a purchase would buy a Mercedes? So we look at female, Mercedes. 78%. Yep. So female purchases, Mercedes. So 0.78 or 78%. So C, it says, what's the probability that a male would purchase a Ford or BMW? So if a male is purchasing a Ford or BMW, in this case, we would have to add the 2 probabilities. Now, this question's a bit of a redundant question or a dud question because what we're trying to compare here is male to female purchases. So we can't compare what 2 male purchases would be because they're going to add up to over 1. So in this case here, this is just to show what happens when we have bad data in Excel. You have to be able to recognize things that don't work because just because Excel is good at managing and analyzing your data, it doesn't mean that it's always going to be right. Because here I could very easily say, yep, Ford or BMW means we're adding those probabilities together. Therefore, the probability is 146%, which isn't true because that's just saying that the probability is definitely going to be over 1, which we can't have. So make sure that for that, you are cautious of what data we do have and how we use it. So that was just the point of that question there. Yep, so did we have a question? Saw a raised hand. No? Okay. So if we look at the females buying a Nissan or Vauxhall, in this case here, we can say that it's, again, the question doesn't work if we're looking at what the data is that we have, but in this case, it doesn't go to 1. So we can make that comparison here. So if we want a Nissan or Vauxhall, we could add up these probabilities. It's technically not accurate because we're comparing different genders. So the only way it would work is if we said a male buying a BMW or a female buying a Ford, for example, but we still have the data. So we would have to change it a little bit if we were actually using it properly. So we'll leave C and D because we know that this is poor data. Now, again, for the last one, it says, what's the probability that two females would purchase a Fiat and Mercedes in succession? So this one we can do, because this is talking about what is the probability that we'll get a Fiat and Mercedes in succession. Now, when we're doing probability and we're talking about things in succession, that's where we multiply our probabilities. Again, this is not so important in terms of the context of what we're trying to do here, but it's just a good understanding. So in this case, we want probability of a Fiat times by, so this little asterisk means multiply, the probability of a Mercedes, and then we can press enter. And then we get for E, our answer is 0.7. So probability that we get that in succession is 0.7. So it's quite high. So this was just a bit of an exercise to show how you can start to use data and how you can graph it and show it. So the main aspect is not really the actual data itself as much as what you can do with it or how you can play with it. So that's, I guess, a general introduction. There is another question there, which I will leave with you guys to do as a homework task or as a check. All you're doing is different averages and plotting things. So again, if we're using averages, equal average is the cell we're going to be using. So have a play around with that data and see what you can come up with that. So I'll go back to slides now. Okay, so this is pretty much what we've done today. So we've gone through that problem. And this is the problem that you guys can do in your own time to have a check. So we are coming to our conclusion. Just before we do get there, just make sure that for those of you who haven't messaged Mackenzie, please message her with your student numbers and names if they're not on your name in here, just because then we can keep track of that and give you guys any extra information that might be needed. So to summarize, Excel is very powerful overall and is quite used in most scientific industries. Speaking from experience as an engineer, we use it quite a lot in research as well. So it is quite broad and applicable in a range of different scenarios. So it's very important even to have this basic understanding because it's very easy to build off that. So today was a very basic program. So if you found that you knew a lot of it, feel free to come tomorrow where we'll do a bit more advanced stuff on things like VLOOKUP and how we can use that. But it is important to note that Excel is very important in STEM programs, particularly when you're using it for big data, which a lot of you will do for your thesis. And it does have quite a broad application. So more employers are looking for graduates that do have this base level of Excel knowledge because it's a critical tool or program to use for different applications. So hopefully that's given you guys a good insight. That's pretty much covers what we need to cover for today. So I'll stop